Hey class, good to see you through video. I just wanted to take a quick minute to go over some things in 5.2, and hopefully this video will help supplement your textbook and your homework problems. So 5.2 is about inverse functions. Definition of an inverse function is the function is a relation that sends b to a if the function of a is equal to b. So what does that mean in reality of doing our problems? It means that if you look right here at the function of a is equal to b, then we can write a new function that says the inverse function of b is equal to a. So that allows us to take the input of the original function and make it the output of the new inverse function. And we will take some practice in just a moment. So, sorry, we're clicking through these slides here. So let's evaluate a function of f and the inverse function. So it's asking us to look right here at the function of 3. Remember that the original notation is a function of x, so that is implying x is equal to 3. So we look over here in the column and we find x is equal to 3, and we find that the output is 27. Now, if we look for the inverse function, we're looking and making the outputs of the original the inputs of the new inverse function. So we are looking at the input being 9, and that maps to the output of 2. So just a warning, when we're looking at inverse notation, make sure that when you see that f to the negative 1 right here, you are not using that as an exponent. That negative 1 is not part of our mathematical computations. It is nothing about all the things we learned about exponents in previous sections. It's simply notation. So you can ignore that mathematically, but pay attention to it knowing that what it's asking you to do is find the inverse function. So let's look at an example. When your book asks you to find the input and output values of the inverse function, first you need to start with a function and find some values. So you're looking at ordered pairs, you're looking at building a table with x and y, and we're going to use the function f of x equals 16 times a quantity 1/2 raised to the x. So when we do that and we look at our tables, we can see that this original function is this table. The inputs are 0, 1, 2, 3, 4, and when we plug those into x, we get the output 16, 8, 4, 2, and 1. When we want to find the inverse function, the values that were the output become the input. The values that were the input now become the output. So it's important that you can build your new table from your old table. So this function of x table is something we've been doing for 5 chapters. You're going to continue to do that. To find the inverse function, you're reversing input and output. Now, what happens to graphs of inverse and functions and their inverses? So let's take a look at the function f of x is equal to 2x. Look at its inverse and then also look at the line y equals x. So first we start with our table. F of x, remember, is 2 of x, 2 to the x. So when you plug in a negative 3, you get 1/8. When you plug in negative 1, you get 1/2. 0, 1, and so on. So this original table is for f of x when that is equal to 2 to the x. The new table for the inverse function, we reverse the input and the output. So you can now see the input is 1/8, 1/4, 1/2, and so on, but the output is a -3 to a +2. So what do we think that that will look like for a graph? Well, if we plot these points from our table, you can see that the original function is the blue function. The blue dots, these are the ordered pairs we found, and the red is the inverse function. This line is the line y equals x because every point on it would be 1, 1, 2, 2, 3, 3, and so on. So you can see that this looks like it's going to reflect over the line y equals x. And when we connect those dots, you can see the graphs a little bit better. So it's easy to find the graph of an inverse if you graph the original function. So always start by finding those ordered pairs, make your graph, draw your line y equals x, and reflect over, and you will find these other points if you did not already build a table. So let's summarize this. How to graph an inverse function. First, sketch the original function. Choose several points that lie on that graph and make the ordered pairs in opposite order. So if you had AB, you now have BA. You plot those points and you will see the curve that reflects over the line y equals x. The last thing I want to cover for 5.2 is the process of finding an inverse model. So we have 3 steps that we follow, and they start out with first start with replacing the function notation, solve for the opposite variable, and then replace that variable with the inverse notation. So let's go through an example. So our original function is f of x is equal to 2x minus 3. Step 1 says replace f of x with y. So now we have y is equal to 2x minus 3. The next step says solve for x. So we're going to add 3 to each side. So we have y plus 3 is equal to 2x. We need to divide by 2. So we divide everything by 2. And we get x is equal to 1/2 y plus 3/2. Now you substitute the notation, the inverse function of y where there was x. So you can see now all the variables have y. The last step is to replace every y with an x. So every place that there was a y, we now have x. And that is how we write, we find the inverse of a function. You're going to have lots of practice with that in your homework, and you'll be able to ask questions along the way. I will make sure that our Course Connect site has a way for you to ask questions, but in the meantime, please feel free to email or text me, and we can go over things that way. We can meet virtually. There's lots of options for you not to feel alone. Now, you can also do this in your graphing calculator. You can double check your work by plugging in 2 different equations, the original function and your new function, and make sure that you get that reflection over the line y equals x. So I will post this PowerPoint and this video on Course Connect shortly, and you can have this as part of your notes to go through the steps to make sure that you can find that equation. In the meantime, let's see if we can go out and look at Course Connect. When we look at Course Connect for this week, you can see that, as usual, your homework problems are here, and they need to be completed by the date above. So you need to have all of these completed by March 26th. Now, I'm not going to be collecting them then, so you're going to hang on to them. Then you're going to come back and I will have other introductions into 5.3 and 5.4 posted, and you will do that work before Monday the 30th. On Monday the 30th, by the time our class meets, you will post your work in the hip points area. So make sure that you upload your homework and any notes that you've taken into this location by the end of class time, 3 o'clock on the 30th. The easiest way to upload your work is to use either like an app on your phone, where HP Smart is a free app, and it allows you to take a picture of your homework and convert it to a PDF. So you could take pictures of every page and then convert it to one PDF file and upload it. You can also take pictures, embed them in a Word document, and upload that. That's much easier than uploading every single question. I expect that you will be taking your homework, doing it, looking in the back of the book for correct answers, and similarly to in class, if you have questions, you need to reach out to me. I am also posting the virtual math tutoring hours, where you can work with the math tutors online through Google Meets, and they can answer your questions as well. So hang tight as we transition this first week, but please get started on 5.2 and start to work through those homework problems so we can see if you have any questions. Have a great rest of your day. Bye.